Hello everyone, this is Sagar from Team 45 for Capstone project of 2022 to 2023. We have made this project on static malware detection under the guidance of Dr. Neeru Jindal and Dr. Shubhra Jain. Our project aims to classify whether a given file is malicious or not using its executables.
We have trained our model using 5800 malwares from Microsoft Malware Classification Challenge dataset on Kaggle and crawled our machine for 2700 benign files. The dataset consisted of two types of files for each malware, namely its byte executable file and an ASM file. Our next challenge was to extract some meaningful features from these files to train our models.
Now I'll tell you how we extracted meaningful features from the .asm files. .asm files is basically an assembly file. This is a structure of an ASM file. When we closely observed the ASM file, we found out that it contained different sections like header, text, data, etc. And these different sections contain information in the form of x86 instructions, or you can say that you can call them opcodes. For example, move, push, pull. After analyzing the ASM file, the best way to extract meaningful features for our ML models was to count the frequency of these opcodes. We trained multiple models on all the possible opcodes, and after training, we found out that using the top 18 x86 instructions gave us the best results. That's why we are using the frequency count of only the top 18 instructions.
So the next type of file is the bytes file. As you can see on the screen, it is just a random arrangement of hex values ranging from 00 to FF. In total, there are 256 hex codes. Now, the main task was to extract something useful from these files. After close examination, we found that if we calculate the frequency of all the 256 hex codes in each file, we could easily build a data frame of 256 columns, and then we could train various machine learning models on it to predict that whether the given file is malicious or not.
Now, let us talk about the machine learning models we have used in our project. We have deployed a variety of machine learning models such as k-nearest neighbors, random forest in XGBoost, and a deep learning model ANN, where we have used autoencoder to reduce the number of features. We calculated log loss by varying different training parameters of these models and selected the training parameters which gave us minimum log loss. For evaluation on these models, we have used parameters such as precision, recall, accuracy, and false positive rate. Our main objective was to minimize the false positive rate, as we didn't want a file that was malware to be classified as benign.